Okay, today we're going to do differential equations, right? So the assignment is right here. Is the release problems you have in the binder. This is consider the differential equation dy dx 3 minus x over y, right? So we have dy dx is 3 minus x over y. And then you have let y equals f of x a particular solution to a given differential equation for 1 through 5, yeah, such that the line y equals -2 is tangent to f. So this find the x coordinate of the point of tangency and determine whether f has a local max or mean or neither at the point. Justify your answer. So esto va a ser largo. This is going to be long. So this is the information you have. This is the differential equation. dy over dx equals 3 minus x over y. The values range from 1 to 5. Yeah. And this is a solution with this tangent. This is a horizontal tangent. Everybody knows that. So y equals -2 is a horizontal line passing at -2. So tangent to dx. So we have to find the x coordinate of this thing, right? So differential equations. Aquí está. Okay. So how do we solve this thing first? It's okay. Well, the first thing is we possibly want to find what is first? This find x coordinate of tangency. So y equals -2. So we know something. So y equals -2 equals -2 is a horizontal line. Okay, so this is not calculus, this is algebra. So if we have y minus y0 equals mx minus x0, right? Means that the m is 0. Yeah, this is algebra 1. So if this is the question of a line passing through this point and with this slope, and this is a horizontal line, then this is the only thing we have. The slope is 0. And here y0 equals -2. Yep. So we have x0 with a note, correct? Okie dokie. So from dy dx equals 3 minus x over y. So we know that at the point x0, y0, m is 0. Or dy dx equals 0. So this is my reasoning. This is the differential equation. In x0, y0, this tangency point, the slope has to be 0, correct? Okay, now we know that y0 is -2, so we have dy dx equals 3 minus x0 over -2, and this has to be 0. So, solution for this problem. So everybody's following the reasoning? So you have a differential equation, right? This is the solution. This is the tangent point in y equals -2. So, okay, y equals -2 is a horizontal line. So that means that y minus y0 is, this is the equation of a line. This means that in x0, y0, the m has to be 0. And this means that y0 is -2, this one. So who's the x0? It says, well, the differential equation is this one. So in x0, y0, the differential equation has to be horizontal. dy dx equals 0 because that's the m, right? So dy dx equals 3x0 minus x0 minus over -2 equals 0. So easily x0 equals 3, correct? So everybody catch the idea? You see, no calculus here. No calculus here, just algebra. And the reasoning that the equation of a line has a slope, and if this is a horizontal line, the slope is 0. So dy dx equals 0. So you can put here dy dx.
Why is it 3? Why is x 3? Why is x 3?
A ver, aquí. What is the solution of this equation?
Wouldn't it be 3 over 2?
¿Qué pasó, ingeniero? What happened? A ver, check this.
No, Leo, you divide first? Or, yeah, you multiply by the other side to get rid of the -2.
Your negative 2 times 0 is 0. 3 minus x0, 0. X0 equals 3.
Yeah.
Oh,
Careful.
okay.
This is an easy equation that you cannot miss. So everybody catch what happened? Yeah, that's the first question. This is find the x-coordinate of the point of tangency right here, and determine if you have a local max or mean. It's okay. How can we know this is a local max or mean? So what are the proofs we have to use? Okay, so we know that these are horizontal lines or horizontal tangents, these ones. So this is the max, or this is the mean, I mean. This is the max. And you know that f double prime of x is positive. In this case, f double prime of x is negative, or the first derivative change from negative to positive, or here the first derivative change from positive to negative. Correct? So this is what we have. Okay? So this is what you found. So x0, y0 is -3, 2, right? So this is -3, 2. So what you have in -3, 2? A max or a mean? Both have horizontal tangents. So these are the criteria to check. F double prime of x positive for a mean, f double prime of x negative, or the derivative change from negative to positive. So which one you want to use? Think. This is what you have. dy dx equals 3x, 3 minus x over y. What do you want to use?
The second derivative one, because we don't have a graph.
The second derivative. Okay, the second derivative looks fine. So f prime of x is dy dx, correct? So this is 3 minus x over y. And we are assuming y is a function of x. Correct? Y is a function of x. Correct? How do we find f double prime? Okay, f double prime of x is the second derivative of y respect x, or the derivative respect x of 3 minus x over y. Correct? Everybody catch this reasoning? Yeah?
Yeah.
So f prime is dy dx. This is dy dx. Then the second f double prime is the second derivative of this, or the derivative of this. Okay. Now y is a function of x, so this is an implicit differentiation thing. So this is a quotient. So this is going to be, now this is the calculus, right? Let me just put here the calculus. F prime of x, dy dx, f double prime of x. Let me just put this in the right color. Okay. So, this is a function of x, so I'm going to use the quotient rule. So it's y times derivative of this is -1. Another color. Minus 3 minus x, 3 minus y, no, 3 minus x times dy dx, correct? Y squared. Let me just put this one, y times negative 1 over this, correct? Okay? Now, I have to evaluate f double prime of x0. So it's in x0 where I want this. So, okay, this is y in x0, because y is a function of x. It's negative y in x0 minus 3 minus x0. But x0 is what? Negative 3, correct? No, positive. No, it's positive 3, sorry. It's positive 3. So this is f prime in 3, y in 3, 3 minus 3 times dy dx, correct? Over y in 3 squared. Everybody's understanding what I did? So is a mean or a max is in x0, y0, correct? x0, y0, 3 comma negative 2. Okay, 3 negative 2, or C. So the second derivative in x has to be x0. Okay, I get the second derivative. So the derivative of this quotient rule, the derivative is this one. And then I'm going to evaluate this in 3. So y in 3, so this is negative y in 3, 3 minus 3, this is 3, times whatever is here, no importa, this is going to be 0 also, y of 3, so I'm going to put the numbers. This is negative, this is y0, so negative negative 2 over negative 2 squared. Okay, what is f prime of 3?
0.
A ver, 0.
Wait.
Remember, you're looking if it's positive or negative, correct? Or 0, but this I didn't put here an inflection point. I just a mean or a max. Positive, negative. Okay. What is this number? Positive or negative? Eh?
It's gonna be positive.
It's a positive. So f double prime of 3 is positive. So the
is it
function
1/2?
has a what? Oh, a mean at x equals 3. Correct?
Yeah.
Clear the reasoning? Yeah. So second derivative in the point is 3 right here. So I put y of 3 because y is a function of x. So y of 3, that's a negative 2. So I'm going to put here the negative 2, negative, negative 2. 3 minus 3 is 0. Okay, this disappears. Y of 3 is negative 2 squared in this case. So this is positive, positive over a positive, positive. So f prime in 3 is positive. So I have a mean at x equals 3. Okay, so this is the calculus you use, correct? This was not calculus. Okay. Well, let me see now the problem again. Yep. Second question. Y equals g of x be a particular solution to the given differential equation in the interval negative 2, 8, with the initial condition g of 6 equals negative 4. Find the solution. Okay. So I'm going to go again, this portion right here. So this is 3 minus x, so y equals g of x. And you have g of 6 equals negative 4. And this is from negative 2 to positive 8. So this is the equation we have to solve. And now this is what we did in class. You have a differential equation right here. Then you assume that y is a function of x. And the function passes in the point 6, negative 4. So it's technically 6, negative 4, correct? or this is the point the solution passed through. Now we have to integrate this thing. So we need to find y equals. So we have to do the separation of variables. So dy dx equals 3 minus x over y. Then I'm going to multiply everything times y. So I'm going to have y dy dx equals 3 minus x. These two cancels. And then I have here an x. So I'm going to do y dy dx equals 3 minus x dx. These two cancel, and I have y dy equals 3 minus x dx, right? And to cancel this dy, I need to integrate, as we did in class, right? And then I have here the point. In 6 is -4, correct? So we can do the variable of integration, whatever. So this is y squared over 2 equals, this is going to be 1/2 3 minus x squared negative, I'm going to put here, equals -1/2 plus the constant of integration, correct? All right. Everybody catch what happened from here to here? So the integral of y is y squared over 2. The derivative of this is y. And the antiderivative of 3 minus x is 3 minus x squared times 1/2 negative. If you take this derivative, you're going to get 2 times 1/2 cancels. 3 minus x times -1 times this -1, you get this one. Okay? So this is my solution, so I need to determine the z. Okay? That's not algebra, that's not calculus, that's algebra. So for x equals 6, y equals -4. So I'm going to put here -4 squared over 2 equals -1/2 3 minus 6 squared plus c. So the only have to do is put these values in this solution to find the z. So is what I'm doing. So this is going to be 16 divided by 2. This is going to be 3 squared divided by 2, right? Plus c, correct? Now, c is 8 plus 9/2. So c is going to be 16/2 plus 9/2. So those are 25/2. So my solution is going to be y squared divided by 2 equals -1/2 3 minus x squared plus 25 over 2. Okay? Now, are you done? No, because you need to give y equals. This is y squared. So I have to continue with my algebra. So I'm going to solve for y. So I have y squared equals 25 over 2 minus 3 minus x. This is not this one. Square is right here. Yeah, x squared. Correct? So what I did, I multiplied times 2, and this times 2, so it's 25. Now, this is fine. 25 minus this, okay, is this one. So the only thing I have to do is square root. Okay, y equals positive negative square root of 25 minus 3 minus x squared. Now, positive or negative? What do you think? Which one of the roots you are going to select?
Positive.
Why?
La que se mira más bonita.
A ver,
Sí.
fíjense bien en esto. For x positive, the y is what?
Negative.
So what you have to choose here?
Oh, negative.
Y equals negative square root of 25 minus 3 minus x squared. Be careful. You have to be consistent with the points. is because y is negative 4 when x is 6. Okay? Because you use the initial condition. Okay? Now I want you to check the calculus and the algebra. Okay? So all these problems require you be fluent with your operations, with your solution of equations, with how identify you have two solutions, in this case, positive or negative. Which one you choose is because the initial condition, the y has to be negative. So you have to take the negative. If you put a positive, even if you put here a 6, this is going to be positive. So you need a negative outside. Everybody? Yep. Everybody alive? Yep. So this problem was 2002, no calculator. Okay. So now, before I move, no questions here? Everything clear?
This is not going to be on the test, right?
I don't know. What is going to come in the test? No idea. The only I know is you have two problems. Let me see something here.
Because you said that like the last topics weren't going to be on there.
Mm-hmm. Let me see. Well, remember, any topic may come here. Let me just see. Let me just check my email. I received something interesting for you. Here is important. No, right here. Let me just. Master in Science and Applied Data Science. Okay, that's not a different thing. Introduction, welcome. Oh. Did you send me an email with instructions for you? Where is it? Amber. Castillo. Okay, right here. And I want, you see this one. Can you see that? Oh man. Oh, why? Va para atrás. Oh, here. A ver. Can you see this screen, final steps before the AP exam?
No.
Ok, déjeme entonces volverlo a hacer sharing. Okay, now you see that? Final steps before the AP exams?
Yep.
Okay. This is very important, I guess. You were, you received this email also, I guess, pero en caso de no está aquí. Dice, AP exams begin on Monday, May 11, next week. We have outlined steps you should take to ensure your students are prepared to the test. Now, share the AP testing guide. Aquí hay un testing guide. Let's see if I have this contact direct. Okay, here is a PDF. Okay, I'm going to put this one in the Google Classroom, so don't worry. Oops. What is this? Ah, man. Aquí está. Okay, so this is the one. The exam demo, if you can take a practice in the AP College Board website, good idea, right? I'm going to put this resource list also in the Google Classroom. And here are instructions, right? I'm going to have this. You have your ticket. Yeah. And the AP exam, the checklist. I'm going to put this one also in the Google Classroom. And these ones, right? This remind students to click the e-ticket to check in 30 minutes before exam start. The students should allot 80 minutes for each exam, 30 minutes in their APAD, name and other information, and 50 minutes to draft and submit the responses, right? Make sure your students know their local testing time. since each subject exam will be taken simultaneously worldwide. Ensure your students know what to do if something goes wrong. A student accidentally closes the browser, the device crashes, or they temporarily lose internet access. They can quickly click their exam e-ticket again to return to the exam. Okay? And there is here more information. So it's next Tuesday, okay? We don't have too much time. Okay? So I'm going to upload those documents in the Google Classroom. You can see them, or possibly you have the email and you can see them in the College Board site. Okay? Well, let's continue with more problems. So share screen. Here is the thing. Next problem. Yep, it's pretty much the same. This is let f be the function satisfying f prime equals x square root of fx for all real numbers x, where f of 3 equals 25. Find f double prime of x and 3, and then write an expression for the solution by solving the differential equation, this one, with the initial condition f of 3 equals 25. You think you can begin this by your own? Before I do something? Remember, you need to find f double prime. So what you have to do here? Get the derivative, and then you are going to use what? This condition, correct?
Yep.
Okay, go ahead. Try A before I do something and show you the answer. Share. Record the thing. So you have f prime of x equals this, x square root of fx. This is your initial condition. You need the second derivative in 3. So to get the second derivative of f, you have to get the derivative of this portion. Using the product rule, derivative of this times this plus this derivative of this right here. F prime is given here, so I substitute f prime in the expression so I can cancel the square roots. And then I get that f double prime of x is this expression. Then I have to do only is evaluate in 3. I know that f in 3 is 25, so square root of 25, 5 plus 9 over 2, 19 over 2. Okay? Easy? Well, let's see the next one. Okay, it's write an expression right here. It's write an expression for the y's, the solution, by solving the differential equation dy dx x square root of y with the initial condition f of 325. So again, what we did in class. So this is dy dx equals x square root of y y of 3 equals 25. Okay. This is what I put on my board, correct? So from this equation, we did this one. So the y is the f. So the y dx equals x dy, square root of y. And this is the initial condition, correct?
Wait, what's the question again? Let me.
This one. From this
What are we
one,
trying to find?
the solution, we are going to find y.
Oh, okay.
They ask you, find y equals fx. Y equals f of x. What is the answer? So I need to solve it. Okay. What you have to do here? You have x's and y's mixed. So what you have to do?
Oh, put them on one side.
¿Cómo empiezo? How do I begin?
You move the
Multiply
dx to the side.
Okay. So multiply the equation by
dx.
Dx. Okay. dy equals x square root of y dx. So that's quickly. Now what?
You integrate? Oh no. You move the y to the other side, right?
Okay.
Divide by y.
So dy square root of y equals x dx, correct? And this is y to the negative 1/2 dy. But that's algebra. So this is y to the negative 1/2 dy equals x dx. You see that? Okay, now what is the next step?
Now you integrate.
Correct. I integrate. So line here. So I have to integrate. So integral y negative 1/2 dy equals the integral x dx. What is this integral? Is 2y to the 1/2, right? Equals x squared over 2 plus c. Remember, I just put one variable, one constant of integration. Now, what is next? I need to what?
Solve for c.
Correct. Using?
Plug in.
Correct. So the point is 3,25. So this is the x, this is the y, correct? Is what this condition means. Okay, so the only have to do is put here a y, so it's 2. Oh, well, that's not calculus. That's basic algebra. 225. Well, this is the square root of 25.
So 5.
This is 3 squared over 2 plus c.
So 9 over 2, 6.
Yes. And this is 9 over 2 plus c. So c is what?
10 minus 9 over 2.
10, and that's equals to?
10, 6.5. No. No. 5.5.
Okay. 5.5 fraction 11 over 2. So my solution, right, is 2y to the 1/2 equals x squared over 2 plus 11/2, correct? Are you done? No. Why? Because you need what? Y equals?
F of x.
What you have to do here?
You have to solve for y.
Okay, I do what I do with this 2. I divide by 2, so I have y 1/2 is x squared over 4 plus 11 over 4, right? And next, what?
Take the square root.
Oh, no, yes. I cancel the square root. How?
Square it.
Correct.
Square both sides. Oh.
That's my answer. Be careful with what you have to answer. This is correct, yes, but this is an implicit solution. You need the explicit solution, y equals. So once you have your constant, You see? You plug it in, then you solve for y. And then you get y equals. Okay? You see how much algebra and how much calculus you have? Okay. Okay, questions? Is fine?
Nope.
Okay.
Yep.
What you are going to be doing tomorrow? Well, we are going to do the next problem, right? That pretty much goes the same. So you have to solve this differential equation in this portion, right? Find a particular solution, you see, when the f is 0. So it's the same procedure, right? Here you have slope fields. You remember how to do the slope fields? If you don't, I'm going to do this next class, okay? So there are several problems with the slope fields. They're pretty much the same thing, you see? You see, all the next ones. Then we are going to do on Thursday, we are going to begin backwards. So we are going to begin in this direction, right? Yep. Okay. I guess we did some of these ones, right?
All right, Ramirez. I'll see you tomorrow. I have to go.
Okay, no problem.